All right, so on this guy now, we're going to be finding each of these composite functions, but then we're also going to find their domain. All right, and so we'll talk about how we find that. So let's start with this guy right here. All right, so we're trying to find f or g of f of x. Okay, so that's the same thing as saying g of f of x. Okay, so g of f of x. So can't we replace f of x? Well, we know what f of x is. F of x is x squared plus 3. And we know that because that's given to us. F of x is x squared plus 3. Okay? So now we need to find we need to find g of x squared plus 3. So that means we replace this x with x squared plus 3, which means we replace this x with x squared plus 3. All right? So g of x squared plus 3 is 1 minus 4 times x squared plus 3. All right, now let's simplify this guy. 1 minus 4x squared minus 12. Okay, so I just multiply negative 4 times x squared, negative 4 times 3. And now we can combine that and get negative 11 minus 4x squared. All right, so that's the first part. It says find the following. So we found it. Now we want to give its domain. Now, how do we find the domain of a composite function? Well, it's really just finding the domain of just this itself. It's actually not very complicated at all. So basically, if you know how to find the domain of just negative 11 minus 4x squared, then this is pretty easy. If you're still sketchy on like, well, how do you even find domain? Check this out. I got your back, dog. So if you want to find the domain of negative 11 minus 4x squared, this is the question that I want to ask. Is there any number that we cannot plug in for x? And you say, well, how do you know if there's a number that we can't plug in? Meaning, is there a number that when you plug it in, it's not possible? Like, for example, when you have a fraction, like if I said 2 over x, what number can you not plug in for x? Oh, well, 0. Okay, well, that's the question that I'm asking right now is there a number that we cannot plug in for x? Well, the answer is no, right? I can plug in every negative number, I can plug in 0, and I can plug in all the positive numbers, and we're going to get a value. So that means that the domain then will be all real numbers. Okay, because if you have a restriction, then you would say, oh, all right, it's all real numbers except this guy. So in this case, it's just going to be all real numbers. And you can verify this graphically if you want to graph this guy. And it will look something like this with the vertex at negative 11. We'll say this is negative 11 right there. And it's going to open down. So it will look like this. It may be a little skinnier here because it has a 4. But as you can see here, it's going to use all of the positive x values. It's going to use all of the negative y value or negative x values and 0 to graph this parabola. So the domains are real numbers. Let's come over here now. And we want to find f of g of x. We can replace g of x. G of x is 1 minus 4x. So now we want to replace this x right here with 1 minus 4x. So it's going to be 1 minus 4x squared plus 3. Okay? Again, I just replaced this x with 1 minus 4x. All right, well, if I multiply this out, that means 1 minus 4x times 1 minus 4x. This would be a 4x there. Let me just erase that little guy. Plus 3. Okay, so if you FOIL this, you'll get 1 minus 8x plus 16 x squared plus 3, which is then simply, and I'm also going to write this in descending order, 16x squared minus 8x plus 4. All right, well, again, the question is there any value that you cannot plug into this? Well, there isn't. Like, you can plug in all the negatives, you can plug in 0, and you can plug in all the positive. So the domain will be all real numbers. Okay? And before we stop this example, I just want to show you what are some additional notations how you can write all real numbers. Okay? So you can write it also as, okay, so if you put the capital R with a little line like that, then that means all real numbers. You could also write it like this, as from negative infinity to positive infinity. Okay, this is using our set notation right here. or actually, I'm sorry, this is interval notation. Or if you want to use set notation, then you would put our bracket right here, which means the set of all x values such that x is equal to all of the x values. So really, all three of these are equivalent. They mean the exact same thing. So it doesn't matter which one you use. Just to kind of expand your knowledge of the way that you can represent all real numbers.